Hello, my name is Anthony and welcome to the Whitebox Geospatial YouTube channel. Today I'll be providing a short tutorial on how to use the Time and Daylight tool in WhiteboxTools. The Time and Daylight tool is an interesting and unique tool to WhiteboxTools. It calculates a portion of the time the sun is above the horizon that a site is in daylight for. It uses a 0 to 1 scale where 0 represents that this location is not in sunlight for the specific time range, and a value of 1, which means that this value is fully illuminated or receives it is always in daylight for this time period. Before I actually get into the tool itself and the WhiteboxTools user manual, I just wanted to explain the data set we'll be using. So this is a digital surface model for a location near Guelph, Ontario, and we're going to be using a digital surface model as we need these features that will actually end up casting a shadow on nearby areas, such as forests, these hedgerows, and also the buildings from farms. So now that we're familiar with the data set, let's actually head over to the WhiteboxTools user manual for the time and daylight. So as I said, this tool calculates the portion of time a location is within daylight. It calculates a portion of time during a user-defined time frame that a grid cell in an input DEM is outside of an area of shadow cast by a local object. This tool operates by calculating a solar almanac, which estimates the sun position for the location in latitude and longitude. So this is an example of the Time and Daylight tool. It shows an urban area, specifically the University of Guelph campus. As you can see, this area here is a little bit darker, which represents that it's not always in daylight as a result of the shadows cast by these buildings. And in comparison, this area over here, which does not have any freestanding features such as buildings or forests, is more shown in a lighter color, which represents 1, and that this area is constantly in daylight more than this area. These are the parameters. There's actually a lot of parameters for this tool, probably the most we've done in these videos. So I'll actually break them down when we actually talk about the tool itself when we're running an example in Whitebox Runner. But now that we're familiar with the tool and the parameters, let's actually head over to Whitebox Runner where we will run an example. So I'm just going to change directories to the location where my Whitebox environment is. Once in my Whitebox environment, I'm going to run the command python3 wbrunner.py, and this will launch the WhiteboxTools front end Whitebox Runner. I'm just going to search for the tool today. Time and Daylight. So we're at the first input parameter is the input DEM, so let's go ahead and grab that. We're just going to call the output test.tiff today. We're going to leave the azimuth fraction with a default value of 10, and same with the maximum search distance. The center point latitude and longitude. As I said, this is an area near Guelph. It's not specifically Guelph, but we're just going to use the lat and longitude for Guelph today. I've extracted these values previously. So the latitude is 43 degrees, 5448, and the longitude is negative 80 degrees, 2482. The UTC offset, that is a searchable parameter. So the UTC offset for Guelph is -4 hours. So I'm just going to go ahead and enter -4. The start day and the end day. This is an interesting and customizable parameter that the user can control before running the tool. So by heading over back to the user manual, users may alternately restrict the time of year over which time and daylight is calculated by specifying a starting date and an end date. You could think, for an agricultural example, a person may want to know the duration that their field is within daylight for a growing season. Let's say May 1st to September 25th, the growing season for a given crop. And they could calculate how much, the duration that the portion of the time the sun is above the horizon that the site is in daylight for. So that's very interesting. And same thing you could be used for the start time and end time. So you can specify a specific time range, such as maybe 8 a.m. to 4 p.m. Or what I like to use is sunrise and sunset to account for the full day. So let's head over back to the Whitebox Runner and start to enter these parameters. So I've just picked an arbitrary day of May 13th for the start day and September 25th as the end day. This tool requires the start and end date to be in Julian days. So May 13th is day 133, and September 25th is day 268. And for the starting hour, I'm just going to use sunrise and sunset. So now that the tool is, all the parameters are set, I'm going to go ahead and run the tool, and I'm just going to pause the tool when it's running just to save a bit of time. So the tool executed in 9.3 seconds. So let's actually head over to QGIS and we will view the output of the tool. So we called the output test.tiff. So there we have the tool output itself. Let's actually zoom in a bit more. So as you can see here in the middle of the agricultural field, you get a value closer to 1, which represents that this location is more frequently in daylight, and there's actually no shadows cast around it. But you can see over here there is a little bit of a darker color, which represents more that this location is more in shadow for the specified time range as a result of this forest. Same over here, the same phenomena is happening with this hedgerow, which you can see, and you can see the shadow cast as well. And same with the farmers, the farm itself. There's some shadow cast around this area. This is a very interesting output, I would say. It can be useful for predictive modeling applications as an input covariate. Commonly aspect and relative aspect may be used as input covariate for predicting yield, and this tool could offer additional information that maybe aspect and relative aspect do not offer. So check it out in WhiteboxTools. And thank you for watching this video. Please like and subscribe to our YouTube channel. Thanks.